Hello, my name is Gary Patti. I'm a professor at Washington University, the Michael and Tana Paul Professor in the departments of Chemistry, Genetics, and Medicine. I also serve as the director of the Clinical Research Center and the director of the Center for Mass Spectrometry and Metabolic Tracing. So if you imagine that you take a blood sample and you evaluate it on a mass spectrometer, and you see 25,000 signals, and only 5% or less represent biologically relevant compounds, then the instrument is spending a lot of time collecting data for analytes that in the end, you're just filtering. That can be useful because although we've worked really hard to develop software tools and other groups have worked really hard to develop software tools they've become pretty fantastic. They aren't perfect. So it's good to have the data because we can go in there and maybe find something that we didn't expect. But if you can filter that and you can do it effectively and successfully, and you can really narrow down to the 5% or less of the signals that you care about, it raises the question of whether or not we should be doing experiments looking at all of those 25,000 signals, or can we really just do a targeted analysis and focus on the few thousand signals that we know are important and that matter. So I think that's where the Thermo Scientific Stellar Mass Spectrometer is really the perfect instrument, because you get the best of both worlds. You get the targeted, you get the benefits of the targeted space and the benefits of the untargeted space all wrapped together in a single instrument. And then think about targeting those specifically on the Thermo Scientific Stellar Mass Spectrometer.
My name is Kevin Cho, a director of operation at the Center for Mass Spectrometry and Metabolic Tracing. One of our major goals is to provide all for the researchers' biochemical needs, including untargeted metabolomics and lipidomics. The beneficial of using Thermo Scientific Stellar Mass Spectrometer is that we're doing large study, and this robustness as well as easy to utilize the instrument will be crucial for handling those large sample set. But plus, it's not only just where MRM, you can only target one, but this is PRM, so there's a lot of unknowns that we haven't identified. We still have this information, and then we can go back, we can identify those unknown compounds. Plus, it's not just those data acquisition, but it has MS3 capability that some of those not fully annotated compound, we can do more in depth to cover and identify the unknown compounds.
It's intriguing to think that you can measure 25,000 signals with an instrument doing an untargeted analysis, pick out just the 1,000 or 2,000 that are biologically relevant, and then move those over to a different instrument and just profile those. It sounds simple enough. But how do we among the 25,000 analytes, how do we find those that we want to switch over? There's a whole suite of software tools that are available. Some of them are developed by academic labs like ours, but there are other software tools that have been developed by Thermo Scientific. If you look at the Compound Discoverer suite, for example, it has capabilities to look at the 25,000 signals. And I'm just using 25,000 as a number. It's not exactly 25,000, but thousands and thousands of signals, and go through it and find the fragments and find the adducts and find the various salts and all those sorts of things. So my dream is to be able to take mass spectrometers and to perform multiomics analysis, specifically proteomics, metabolomics, lipidomics, and exposomics at the same scale that we perform genomics. If you're thinking, well, let's get to millions and millions of samples, not to say that it's not plausible, but there are barriers there when we think about standard instruments for discovery analyses that will make it more complicated. And so I think the Stellar Mass Spectrometer plays a really critical piece here, because it gets you the same information at a lower cost point, your standard discovery instrument, but you're not sacrificing anything. And the instruments are more robust and they're quantitative. So in my view, it's going to be an absolutely integral piece of population health, multiomics profiling at large scale levels as we try to tackle this enormous problem of profiling hundreds of thousands and millions of people.